Good afternoon to all of you. As far as previous class is concerned, in previous class we have discussed entity integrity constraints. These are the constraints which we have taken into consideration. And within this, we have completely discussed regarding to primary key activity. What are the specific activities of a primary key? And what are the specific activity of unique? So primary key is the combination of unique and not null. If you combine these two, whatever the operations you have combined here, if you combine those two, so then we could get the primary key activity. Whereas unique in the sense, this unique is always trying to take the value. That value might be null or might be exact value, might be null or might be exact value. If it is null, there is no checking with the previous rows. If it is actual value, it is going to check with the previous rows that the value which you are going to enter into that particular row, new row, will be duplicated with any other values or not. Okay. Any other values or not. If it is duplicated, unique is strictly give you one particular error message that uniqueness is violated. Already we have seen some error messages in the previous class. So this is the specification. We have learned something about entity relationship. Entity integrity constraints. Entity integrity constraints will be taken in such a way. Then today, we'd like to concentrate on referential integrity. Of course, wanted to specify something about referential integrity. You are expected to have some information of primary key also. That is why in our today's topic, I have given entity and referential integrity constraint. That is the topic name I have given today. Okay. So, what is a referential integrity? Then how this referential integrity will be gets operated? Let us have a look here. So before going to take this particular thing, so how a primary key can be gets added to an existing table, to an existing tables column. How that could be gets added? Previously we have seen, and one error message was displayed while you are trying to introduce null value, not null constraint to on a particular column. So how that could be get added using alter table command. Let us have a look here. Okay, so AMR class again. Yeah, successfully log in here. So look at this. So set line size 300. Set page size. How much it is? Page size is 50. Okay. Then select everything from TAB. So here one column is there. I'd like to rename. I'd like to adjust the column name so that everything will be gets adjusted in a proper way. Column name is tname format some 20, for example. Okay. So let us take the specification. Yes, everything will be displayed in single page so that everything will be done here. So let us go ahead and have some kind of descriptions or table structure displays for this admission, for this particular admission or admission 1 or admission 2 or student exam, something like this. DESC, STUDENT, and STUDEXA, student exam. You can see. So here registered number, there is a column here, registered number, but this registered number does not have any impose of any constraint. There is no constraint which was enforced on this particular registered number. So wanted to enforce any constraint. Let me say that is primary key on this registered number of a student exam. How this could be done here? Let us have a look here. So take this one very carefully. If you have notes and pen with you, so then it is very important because of course in the final year. So many HRs are being asked this particular question. How could you add a constraint to, or how could you enforce a constraint to a column externally, not internally, externally? How that could be happen? So look at this. Alter table. Table name is stud underscore exam. Then what I'm trying to do, I'm trying to enforce a particular particular constraint. Enforcing in the sense adding one particular so constraint here. So how that could be done? We're trying to add constraint. So we have to specify constraint physical name. So what is it? Sorry, logical name. How could you specify? Stud underscore exam. This is the constraint underscore pk. Pk in the sense primary key underscore on which register on which column you are enforcing this. Regd underscore. Okay. What is your constraint here? Name of constraint is primary key. Primary key of on which column it is? Regd underscore n1. Register number. Okay. If a table gets altered. Your table gets altered. If you describe this particular table one more time, you could get a null here. You could get null here. So not null has been enforced, that unique also enforced. You could get null here. So let us take one more time the description, table description. Yes, you can take this here. Not null also be enforced here. Not null was enforced here. Of course, unique also be there. Unique also be there. So if you have any questions, then I'd like to select everything from user underscore constraints table, refer this particular table. Then you could get some information. So where exactly the things will be. Let me see that. Okay, I'd like to display only our table. I'd like to display only our table. So only our table information, user underscore constraints, where table underscore name is equal to student stud underscore exam. Only this particular table information will be gets displayed. You can see here. So AMR class is the owner. Stud underscore exam underscore pk underscore register number underscore register number. So we have taken this one here. On this one, what we have defined here is P. P in the sense primary key. P in the sense primary key. I'll give you what are the aggregated forms of this thing. I'd like to give you. So what is the table name? That is student exam. So here what we are trying to do, enabled and not differentiable. It could not be deferable and immediately validated and so on username. And when we have created thing is 22nd May 2021 and the username is AMR class and again this one here. Okay, let me give you. So what are the aggregated forms of constraints here? Aggregated forms of constraints will be, so if a primary key can be mentioned, if you are supposed to primary key was enforced on one particular column, then while taking the information from, while referring the information from user underscore constraints, so you could see instead of this primary key complete by name, it could be displayed P. And then when you are enforced unique, it could be displayed so U, capital U. And when you have to CHECK check, then it could be displayed C. And for not null, it could be displayed again C. Both not null check will be taken C only. For foreign, F-O-R-E-I-G-N, foreign key. If you take this one, so then it could be taken R. Referential key R. Okay. So these are the aggregated forms. So then you have to look into or refer the user underscore constraints. Thereby you could understand. Okay. Somehow that is the way how the primary key it can be where it is. So this is the query actually. Primary key can be enforced, something like this. Externally, something like this. Okay. So in this way, you can externally enter the primary key. Now we'll go ahead with the foreign key. We'll go ahead with the foreign key. Let me open MS Paint, because to explain foreign key we require huge explanation. So let me take that particular explanation at this particular point of time. So what is that explanation is, so foreign key, any foreign key explanation is required. So you need to know something here. Foreign key will be always applied on so two tables. Okay. So within this particular two tables, one particular table will be called as, so within this particular two tables, so one table will be, so first table will be called as, so parent table. Second table will be called as child table. If you consider one parent might have many children, that is the general rule. Okay, so that is a normal rule. One parent might be have n number of children. There is no problem at all. If you consider one particular child always mapping with one parent only. If you just remember yourself the tree structure. So this is the parent and does have one particular child, one more child, one more child, one more child. Okay, for this one, so one more child, and one more child. But if you refer, so this is the parent one, and this is actual parent P. And if you refer this particular parent one have for three children. If you refer this particular child, it does have only one parent, and this child also only one parent. This child also only one parent, something like that. So this rule will be always always satisfied, or it could be always satisfied by foreign key here. Foreign key can be always refer the key of parental table. Let me explain with an example, then you could understand. Technically, I am speaking. Probably the technical representation could not understand by you. So let me explain by taking one example. Let us consider. So this is the parent table. This could be the parent table. So this parent table name will be admission, ADM, admission. And this could be the child table, one of the child tables. So after taking the admission of you in any college through MSET or management, you are expected to apply for examination. You are expected to attend the classes to get the attendance. You are expected to, if you are eligible, you are expected to apply for scholarship. So and so operations. Within that particular regard, with respect to student information system, within that particular regard, I'd like to take two tables. One is admission, second one is examination. For example, examination. So if you consider these two, so admission table does have a structure that is a registered number, then followed by student name. Let me write in a smaller way. Student name, so date of birth, and then date of join, otherwise course join, CJ in the sense code join. So date of join of blah, 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 and so on and so forth. Many number of columns are there. In examination system, there is a particular column that is a registered number, and then subject 1 marks, subject 2 marks, and so on, blah, 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 blah. You have many. Within this particular regard, there is a student with me. The student number is so 19501 is there with me. So and I am supposed to enter in examination one more number 19. So let me consider 592. So I'd like to enter this particular number and this particular number. I am conducting examination for these two people. Does 19501 is eligible to take the examination? Eligibility in the sense, don't consider that whether he is completed previous courses or not. Already they have joined, if you consider something like that. So does this particular fellow is so eligible to write the examination? Yes or no? Probability will be there. There might be yes, there might be no. Because we don't know whether this particular 19501 will be existed with admission or not. We don't know exactly. We don't know. Then how could you know this one here in the sense? On examination table, if you define any foreign key, then you could know that whether this fellow is available with the admission register or not, or admission table or not. If you are not supposed to define any foreign key here, no foreign key is being defined by you here, any number can be accepted. 592 can be accepted, then followed by any number 95950. So then you can 401, 405, everything is accepted. If you are not supposed to define any foreign key on examination. If you define something like that, so obviously, so you may be, so refer always admission register that whether so-called 501 is existed, so-called 592 is existed, so-called 50 2 is existed, and so on and so forth, Everything will be existed or not. So how could you define here in the sense? Normally, so this particular definition of foreign key will be, I'd like to show you. So while foreign key can be defined, so this could be seen like this. Single underline can be taken, that is called as primary key. Double underline can be taken, then that is called as foreign key. And from here to here, there might be some logical relationship. So here, one record of admission, so many number of records of examination. So one particular person, so far you have written approximately many number of examinations. Mid examinations are wrote by you, and external examinations, first semester, 1, 1, 1, 2, 2, 1, 2, something like that. Many have been written by you. So therefore, you can take any number of examinations. But in admission register, your admission number could be, register number could be existed for exactly once only. So to mention such kind of relationship, to maintain such kind of relationship, so we have to define foreign key on this particular table, and here primary key on this particular table. This is primary key, and here it is a foreign key. Secondly, the foreign key defined columns are called as child tables. They are called as child tables, and the primary key defined things will be. So if really this register number depends upon admission start register number, then this is called as this kind of specification is called as a parent. So if you have entered any data within this particular system or within this particular table, then immediately she is going to refer with admission, whether really 501 is existed or not. If it is existed, accepted, no problem. He may be taken examination. If he is not existed, 501 is not existed, 19501 cannot be existed, obviously we could say this particular row cannot be inserted into examination because that person has not taken any admission in our college. So that is why he was not supposed to take examination. Really, in your class, so there is no 592, the value 592, this particular reached number is not available. If you are trying to write this particular number on your examination paper, obviously that examination paper will be, though you may be, your number is actually 560, but unknowingly you have written 592, then obviously your examination script will be put into withheld. That is not be corrected. Okay. So to establish such kind of relationship between two or more number of tables, we have to use foreign key. That is the importance of this foreign key here. Let me explain in terms of, this is just a theoretical explanation. Then let me explain by taking the example, same example in technically. Okay, let me clear everything here. first we have to create. So create a table. So ADM. Straight away, I'd like to create the separate tables here. Admission. ADM is admission. Then followed by REGDNO registered number. So okay, let me take the second line. REGDNO. So number of some 5. So which is primary key. It is a primary key. Without primary key, if you define, it is not supposed to be accepted. Then second one is you can take student name VRCHR 2 of some 20, varchar 2 of some 20. So then followed by you can write your own. You can write your own number of columns. That is student name, course date of birth, address, course join, and so on and so forth. You can take any one. But I'd like to stop. Okay, let me give one more. Otherwise, course VRCHR2 of some 10. Let me stop at this moment because I'm trying to give you an explanation point of view. Just let me stop at this particular point. Yes, your table has been created. Now, how could you create? So the child table. This is the parent table, and how could you create the child table? While creation of this particular child table, you must remember two to 3 points. So look at this. 2 to 3 points you must remember. So the points will be, let me write those points here. The points must be, so here, parent tables registered number, a key attribute will be registered number and number of 5. So these are the definitions. So parent tables name will be REGD number. So the data type will be so number of so some 5. While defining your child table, you can put your own name. Column name might not be the same. Column name cannot be same. It is there is no restriction for this. There is no specific restriction. So for this particular point of view, while defining any column name. But in parent table, in child table, I'm talking. In child table, you can give register number or RNO or REGNO. You can give any name. There is no problem at all. Not exactly the same. But data type must be same, and size of that particular data type also be same. You have been defined number. Second condition is satisfied. That is, the data type is same. Yes. Then you may be defined some 7, for example. Size will be 7. Look at this here, only 5, but our child table has taken 7. How could it could be referred? So 1, 2, 3, 4, 5. This is the particular value where exactly available with one of the register numbers. But in the child table, you maybe have to enter 1, 2, 3, 4, 5, 6, 7. Will it be ever equal to this particular value? No, it is not equal. It is not never equal. So that is why size will be always same. Data type must be always same, and the size must also be same. So while defining, remember point number 1. So while defining, so child key, that is child attribute, otherwise foreign key. Okay, so foreign key number 1. So you can define your own OWM, own, so attribute name. Attribute name cannot be the same. You can define it own. But second one, data type of this key must be same as the parental key. Whatever the table you are trying to refer, within that particular table, one of the column will be your parental key. So whatever the data type which could be taken at the parental key, that must be the same. And the third one is size of the of THH. This key must be same as the parent key. So whatever the parent key, you have to consider the same parent key size must be taken. The same parent key data type must be taken. If you forget to taken about these, then it should not be taken into consideration. You please remember this. You please remember these points. So it's very, very important to be considered. Okay. Now, I'd like to go ahead with the SQL and let me define. So create table. Table name is exam. Okay, so here regdno. So for time being, I'd like to give the same name and number of 5. If you give number of 4 or if you give number of 7, it could not be accepted. Okay, then how could you define the foreign key while creating the table? In the sense, while creating, there is no such keyword foreignkey. Okay, there is no such keyword. So here directly references, the references. So where you are trying to reference? So ADM, that is the table name. And which column you are trying to refer? REGDNO, registered number. In this way you have to refer. This references will be always been considered as the foreign key. Then SUB1, of course, number of 3. And if you want to specify your check constraint, yes, go ahead and check specify this one. And SUB2 will be number of 3, and SUB3. Let me stop up to SUB3 only. So let me stop to take up to this particular thing only. Then you can close it. You can close it and put semicolon. Yes, your table has created. Now go ahead and select everything from. So ADM, any data is there with you? No data. So select everything from exam. Any data is there with you? No data. The both tables you don't have any data. Now I'm trying to enter one particular value or one particular row into exam. Insert into table name is exam. So values. First value is, let me say that is 501. And then 3 subject marks, some 45, 54, however, whatever the value it might be, the value doesn't make any sense here. Okay. There is an error. Integrity constraint, so and so integrity constraint, that is parent key is not found. It is referring with one more column, one more tables column. Thereby, you don't have any data which is regarding to 501. You could not find the 501 with the referred table, that is admission. In admission, there is no 501. Now, let us try insert into the table name is ADM. So values, let me enter 501 here. 501 reference will be gets added here. Let me say register number as name course. Okay, register number is so 501. Then name is some name Hari. Then course is CSE. Let us consider this data is entered. This data is entered. Look at this, one row of data is available with admission. Now, we'll go ahead and execute the same query back. Same query back. That query is, so what is that query? Insert into exam. He is, right now, Hari is available with the admission. Now he is trying to take one examination from that college. Now insert into exam, values 501, some subject marks. Okay, let me execute this one. One row is created. Since previously the same thing will be gets executed by you, you got one error message. That message is parental key is not found. There is no data which is referring with parent. In parent, 501 is not found. Because of not having 501, so it has been displayed this particular kind of message. Now you can see I have created one row with admission, which could be pertained 501 here. 501 has been created by me. Now I am trying to insert the same row here. Yes, it could be accepted. Now, if you go ahead and enter one more value, that is 502, 502, really 502 is not existed in our parent. So some row, some values, some values, some values. Okay, some values. So let us go ahead and execute this one. Again, same error message. Because 501, the candidate 501 has not taken any admission into that particular college. Because we don't have any 502 which is not available with this particular admission table. If you have 502 here, then it could be gets accepted and no error message, something like this. Okay, no error message, something like this. So you just remember this. You just remember this. It's very important to remember. So this is the way you have to add a constraint, a primary key constraint on particular column. So let me show you this one pictorially. Pictorial in the sense, one more database application is there in MS Office. That application is Microsoft Access. Microsoft Access is there. Let me show you this. Okay, let me show you. Yeah, blank database only. The database name is second CSE. Okay, let me create this one. Let me create the first structure. Structure of so first table. Create a particular table in design mode. Here, student RNO, student register number. So it is member. Then yes name. Yes name. It is small text only. Of course, let me stop this one. And while defining this one, it is a primary key. You can see key here. Key here. So apply this one. You could get the primary key and save this one. And save this one. Yes, I'm trying to save. This is ADM admission. Yes, one table has been created. And second table is exam. Here also RNO number only. So subject 1 marks. Here also number only. Subject 2 marks. Here also number only. Okay. Now I'd like to define foreign key here. So foreign key cannot be defined at this creation time. So let me show you. So save this one. That is exam. Okay. No primary key is required at this moment. Okay. Close this one here. Now open external database tools. So hereby you can identify relationships. One particular column that is relationships. So add these two into the pane. Into this particular pane, add these two, and you can see two tables are there with us in this pane. So admission is parent because having some primary key, and examination is child. So because not having any key on this one. Now I'd like to enforce foreign key between these two. So here, how could you enforce here in the sense? So carry this one and so leave on that particular column where exactly you have to refer. Yes. Admission table of register number is referred by register number of examination. I don't know whether it is visible to you or not. So in this way. Then here you can see enforce referential integrity. Yes, enforce. You can see one to many. That is one particular thing that is one to many here. Then go ahead and create. You can see one relationship has been gets created. What I have drawn in the previous, what I have drawn here in the previous MS Paint, the same thing will be shown here to you. Admissions registered number, examination registered number is being referred by admission registered number. So therefore, one to many has been gets operated here. You can see this one. It is the pictorial representation to be shown. Okay. In this way, now you can save this one, and go ahead. So close this one here, and then open the examination table. Now I'm trying to enter 501, some values. Okay, whatever the values it may be. So put enter key here. You cannot add or change record because referred record required in the table admission. So in Oracle, you got this particular message. Integrity constraint is violated because what is that violation? Parent key is not found. In MS Access, you cannot add or change any record because the record which is related to admission is not available. Okay, is not existed. So that you could not enter this particular data. Okay, leave it. Okay, leave it. Let me delete this particular data. Let me delete this particular data. Okay, it is not accepting. Close this one. Okay, close this one. Then add one more data here. 501. Yes, name is Hari. And then 502. So some Kumar, something like this. Yes, save this one. Come to this area. Now you can take 501. So you can see, add it. 502. So 23 or 32. 503. So 56 and 72. Now 503 is not available with admission. With admission, 503 is not available. Where exactly you can consider? It is a pictorial, otherwise a graphical user interface. And what you are trying to learn here is the command line user interface. Whatever the thing it might be, everything will be same. Okay. Okay. So let me save this one. Okay. Okay. Yes. Okay. So then in admission and in examination, you can see in admission 501, 502, they have taken first examination. In second examination by 501, 502, yes, you can. Third examination, yes, you can. Fourth examination, yes, you can. Okay. So in this way, you can enter, and you can perform the operations. These are the actual, in our final examinations, I mean, laboratory internal examination, you have to enter in such a way. So thereby, our integrity constraints are gets over. Now tomorrow, we'd like to concentrate on, tomorrow in the sense next class, that is 24/05/2021. On this day, we'd like to concentrate SQL operators. SQL operators and where class in select statement, then followed by functions, built-in functions, better to say built-in functions, TTIONS functions in Oracle will be there. So SQL operators are huge, SQL operators are there. I don't know whether it could be gets completed or not. If you want to execute SQL operators, you must have where class only. If you have where class, then you could able to operate SQL operators. So these two will be gets completed by 24. If possible, I'll go ahead with some more. Okay. Don't go away. I'm taking attendance. Don't go away. I'm taking attendance. That is 27. Yeah. So people you haven't joined, still more number of people are supposed to join to Google Classroom. I have given time to you